let me tell you about 5 cutting-edge virtual production technologies that are so close to changing the industry as we know it. And stick around because you're going to hear from the people behind the technology as well and what they think the future holds. Number 1 is a long-awaited piece of software from Octane Render called Brigade. This is basically their real-time path tracing solution. From what I understand, what makes Brigade actually possible is Octane's temporal denoiser for path traced rays. You can see in this demo video on the left-hand side, that's the real-time path traced, cleaned up scene, whereas on the right-hand side is the normal path traced scene. When they actually let the path traced scene resolve, it ends up looking exactly the same as the temporally denoised version, which is bonkers really. The implications of Brigade are massive because Octane already has connectors and plugins for a whole host of 3D packages, including Unreal Engine and Nvidia Omniverse. When it finally does release, it'll only be a matter of time before you find it in your 3D package of choice. Now it looks like it's going to be bundled in with the 2024 release next year. You could have unbiased spectral path tracing in real time in your virtual production scene. That is massive for photorealism. I'm really excited about this one. Get a look at this video. That's not just me, is it? That lighting match is incredible. So apparently what's going on here is they have about 9 light panels all positioned around the talent to create an even distribution of light, and then they are calibrated by software in order to match the color from the virtual scene. That's obviously a very oversimplified version of what's going on here, so I reached out to Peter from Anti-Latency to tell me a bit more.
We have received applications.
We were surrounded by green. What inspired the need to say create Cybergaffer?
All other parts of the process, you have to install it just once, like camera tracking, background, rendering pipeline, all that you just need to turn on, and that's it. It just works. But that is not true for lighting. Every time for every new scene, you have to move fixtures, adjust brightnesses, colors, and there is no way to do that automatically. I think this is the final piece of a puzzle for virtual production. With this technology, we will be able to install lighting just once. You can use almost any RGBW light. Then this lighting will be always synchronized with the Unreal Engine.
Of course, this is not yet a finished product. What is your, say, roadmap?
Our first goal is to deliver a closed beta in January. We will use that feedback to prepare version 1. We really want to build a lot on top of it.
What is the horizon from where we are now?
In some aspects of virtual production, people keep trying different approaches, and finally it will come together with a more scientific approach, I believe so.
I think the proof is in the pudding here. Those results are so good. But the challenge will be when they start to incorporate multiple people, movement, and blocking. But that's just challenges for down the road. At the moment, this is just really exciting. Let's talk briefly about Nvidia Omniverse. Now, I know that's not new tech, but this is more of a prediction because I think Nvidia Omniverse has an untapped potential for real-time virtual production. There are a lot of great creators using it for CGI short films like JS Films who make amazing stuff, but I'm yet to see it used as the primary engine for VP. Omniverse has some amazing strengths when it comes to 3D content creation. For instance, it has applications in tons of industries like design and engineering. It also benefits from all of the RTX ray tracing technology, DLSS, and all of the AI research that Nvidia does, of which there is a lot, and that's a topic for another video. Plus, their Nucleus server allows you to create large libraries of assets and share them with people across the world. What it lacks is a virtual production toolset. We need video input and output, camera tracking, lens calibration, some grading, and cinematography tools. With a few of these implemented, you could start to see Nvidia Omniverse rivaling Unreal Engine in the virtual production content creation space. So my prediction is Nvidia's going to shake up the game. If you haven't heard about Gaussian Splatting, it's a way of creating a 3D representation of an object or an environment using static images. So it's very similar to photogrammetry in that sense, but these retain reflections, which are notoriously difficult to reconstruct. They also run really fast, so they're great for using in real-time applications like Unreal Engine. So if all of this already exists, why am I talking about it now? Well, take a look at this. A perfect 3D recreation of a person's upper body. It's a Gaussian splat created by Infinite Realities, who in my opinion are at the forefront of using this technology. Watch what happens next. Yes, a moving, fully 3D person. I reached out to Lee from Infinite Realities to tell me more about how this all works.
This year has been really transformative. Really transformative, mainly due to the release of nerf research, so neural radiance fields, nerfs in general, and then this year Gaussian splatting. I mean, even in the last few weeks, the last month, the amount of code releases and research papers that have come out are just insane.
The kind of quality that you are capable of, what does it take to make that?
Synchronizing DSLRs at once in time is very difficult, especially with mechanical shutters. But doing it with video cameras is even harder, and having to do it at a much faster rate, and that's sometimes 30 to 60 times a second. You don't really know how good the data is until you inspect it after the fact. So you have to be really well trained and disciplined and prepared in the setup so that you know the results are going to be good. The
setup that you've got in Infinite Realities, can you just describe what that is to sort of capture your data?
We've got two separate systems. We've got a sphere-shaped head capture system that has 300 plus LEDs on it. It depends what we're doing in the studio, but it'll have between 48 to 56 cameras on it. Then we have another capture system that's a body capture system that has close to 500 LEDs on it. And that rig, when it's fully operational, has about 160 cameras on it. It's pretty mad. I think there's misinformation generally online about what nerfs and Gaussian splats can do, in that you only need a couple of cameras. It's just not true. But as people have shown, you can do some pretty cool stuff with 16 cameras or 32 cameras. We posted an example on our X Twitter page, but it had 20 cameras, and they're quite spread out around somebody in the kitchen. And it works if you're in that frustum, that camera frustum, and you move around. But as soon as you go even 20 centimeters or so out, it starts to break down because that data just doesn't exist. It's not going to build something that it never saw. Who knows where it's going to be in 10, 15, 20 years time. It might be insane. It might be a full-on Star Trek holodeck sort of thing, you know?
Now, I've covered Switchlight on the channel before, and the amount of development they've gone through in the last 5 months is frankly astounding. They were at the time a web application that ran in the browser that would estimate the normals and albedo for any image you fed it, and then allow you to either relight that image or download the maps for use in another application, which I did, and the results are in the video above. But they were one of only 3 applications that did this, and make no mistake, they were the best. I defy anyone to find me a better normal map. I'm currently beta testing their desktop application, which is so much more detailed, and it can take video and image sequences as inputs and estimate the normal, albedo, roughness, and specular maps. Plus, if you're doing your relighting within their application, they can do an extra AI pass, which gives you high frequency detail and subsurface scattering. Quite literally the best relighting I've ever seen. They also now have connectors to Blender and Unreal Engine, meaning you can now export your results out to those pieces of software and it will set up the materials for you. That's really incredible. I had some further questions for their CEO, Hoon Kim. What is the biggest challenge when it comes to video relighting at the moment?
Every single AI product out there that is related with computer vision, it has some problem regarding temporal consistency. We're really working hard to solve this problem, and I think we're really almost there. I'm kind of confident that if we actually launch our product, we're going to be one of the most production-ready AI tools out there.
What do you imagine Switchlight looks like in, say, a year from now?
That's a hard question. What I want Switchlight to be is not just as I told you before, not just the relighting, but we actually want to expand to other territories of VFX and virtual production. We are talking to VFX artists, we're talking to virtual production guys like you. You keep telling us there's more problems to solve. We have great potential to solve each of those problems with our great AI team here at Vivo.
I was curious whether you thought there was any future in Switchlight to incorporate 3D? And I'm sure you don't have any solid ideas, but how do you think maybe that might come about?
Actually, I have a more solid idea than you know, because we've been brainstorming about 3D here at Evil. And okay, so
only say things that you're happy to go in the video.
Okay, if you took a footage with your single camera, maybe you don't have to only do relighting, but maybe you can change the view after the shot was taken. But it's not going to work for every type of scene. It's only going to work on humans. That is something that we are working on. I'm not saying that we solve this or we can solve this. If everything goes perfect, maybe later you won't need to even do the camera tracking because you can change the camera after the shot was taken.
Wow, I think you just blew my mind a bit, actually. I wasn't expecting that. That's incredible. Each of these pieces of tech really deserves its own video, so that's why I plan to cover each of them on the channel as they develop. So if that sounds like it's something for you, then hit that subscribe button just below and the bell notification to stay informed about new videos. And then head over to watch this video to find out why I'm so addicted to filmmaking in Unreal Engine.